Hey guys, I bet you can tell based on my posts on Classroom, I'm not a huge fan of this section. I feel like it probably would have been better just to have taught it to you, the big ideas here. So I'm going to kind of summarize this, and we're going to talk about closure a lot. Closure is an idea I didn't really have much experience with until I was in college, but it was a big idea in college, so I understand what they're doing here. If you are confused about areas of this section, you are going to be 100% okay, because like I said, it's more of an advanced topic. But the big thing they want you to do is they want you to understand this definition of a polynomial. At the end of the section, you need to know what a polynomial looks like. It basically, a couple of you did miss this on the quiz. A polynomial is anything that looks like y or f equals a number, and that number can be anything, x, and this has to be a positive. Actually, it can be a whole number. And then you can add it to a whole bunch of things that look like that. Okay, so like this is a number x to some power plus, and this could be a different number x to a smaller power, so on and so on until you just get to the constant. So a constant function is technically a polynomial, although that's the one that's kind of on the question mark. It's degree 0. Okay, that would be degree 0. Some of you thought lines were not polynomials. Lines are polynomials with degree 1, a number x to some power, and that power is 1. Quadratics are polynomials, x squared plus 1/2 x. You can have a fraction there, plus you can have a square root of 2 here. Okay, cubics, quartics, quintics, all of these are polynomials. And down here, basically, the whole exercise is having you see which ones are polynomials and which ones aren't. Don't get so hung up on the differences and stuff if you can't figure out what they want. Basically, what I want you to like look at those examples. If you can just see the examples, these all are different ways that polynomials can look. But the big thing here is to see what polynomials are not supposed to be. So basically, a variable cannot be in the exponent. You can't have a variable in the exponent. That is exponential, guys. That is an exponential function, and that was actually the answer to that quiz question. You cannot have a variable in denominator. This is called a rational function. This is a chapter I don't think we're going to get to all the way. Well, I know we're not going to get through it all the way. If we have a little summer camp, I'm going to talk to you guys a little bit about this. Okay, this one is looking good. Looks like a polynomial, looks like a polynomial, looks like a polynomial, and then doggers. Right here's the issue. There's no negative exponent allowed because that actually goes back to the last one, because a negative exponent is like repeated division. That would be like 10 over x, and the variable is in the denominator. Same thing here, variable in the denominator. This is also rational, and you cannot have a rational exponent. No rational exponent. In other words, you cannot have a square root of a variable. Square root of x not allowed. Okay, so these are the ways a lot of times that non-polynomials look. Another one that shows up a lot that they don't have down here, anything with absolute value is also not a polynomial. Okay, so that's the big idea on the first page. And now we're going to talk about this idea of closure. Oh, where's my paper? Well, jerk. That seems like a problem. I'm just going to open it up, a new one. I wonder if I pause it. I'm working on it. Look at that. Okay, I'm going to pause it here. Oh, maybe it's here. I'm sorry. Now the video is going to be too long. We're going to start my day like this. I'm going to make a new video on closure. I'll just call this one, "What is a polynomial?" video.